Hello, everybody, and welcome to episode number 20 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. Gavin, we made it to 20.
Yeah, we sure did. We're in the double digits now, and today's an interesting episode. Mike does not yet know what we're going to be talking about,
No, I don't. I've heard good things, but
but the listeners do. So hopefully you're as excited about this as I am. I sort of teased it last week with saying that this is going to be a vaguely Earth Day sort of episode, even though we're about a week late. But last week was a busy week, so it's okay.
also Earth is still around. Like we can still celebrate Earth.
Exactly. But and also, Mike, you sound a little different this week. What's going on?
Yes, I have to keep an eye on my grandfather this week. So while hopefully that nothing will actually show up in the actual final edition of this podcast, if you hear like any like loud snoring in the background or the TV gets turned up or anything like that, just know that my grandfather, just like many of yours, he can't hear so well.
That's all right. I mean, we've listened to Moana on the podcast in the background before, so I'm sure it's fine.
Yes, I'm sure we'll figure it out. But if I do sound a little bit different, that is why. I'm going to try and mitigate that as much as possible. But just so you know in advance.
Exactly. So, do you have any quick announcements before we get into the This Week in Science?
Other than teachers should sleep more. But besides that, I got nothing.
All right. Well, I second that motion. But so this is from. Let me just double check to make sure there's not an actually paleontology related one in here. Doesn't look like it because I just saw this was literally the first one I saw for this week, and I was like, "Yeah, that's pretty cool."
Okay.
But so, do you have a year guess for me?
Oh, 2018.
Oh, so close,
man.
This is from Monday, which was April 26th, 27th.
Oh man, I've never gotten one yet.
I know, and I'm holding out.
I'll get there eventually. As long as we keep doing this podcast long enough, eventually I'll stumble across one.
But yeah, so we have the Cassini spacecraft swoops between Saturn's rings.
Swoops?
That's the headline.
So you might know more about this than I would, but it was always my understanding that like the rings of Saturn and the other planets that have rings, it was like more of a myth, or like not the full story, because it was actually just a bunch of rocks that when you were far enough away they looked like rings, but actually they're not solid anything. So what does that mean?
No, they are chunks of rock and ice that are in orbit around the planet.
So what does it mean?
So they're not solid.
Okay, so what does it mean that the spacecraft? I assume that we've got a paragraph here. What does that mean?
We sure do. So, the paragraph reads, NASA representatives announced that their Cassini spacecraft reinitiated communications after a daring plunge between Saturn and its rings. So it wasn't going in between rings, it was going in between Saturn and the rings.
Oh, okay, I see.
A first for any spacecraft up to that point. Moving at speeds of nearly 77,000 miles per hour. Cassini zipped through a space some 1,500 miles wide, using its dish-shaped antenna as a shield to protect it from potential particles. Because while it looks like, all of the, rocks and ice and things are concentrated in the rings, like they're concentrated there, but there definitely is stuff in between the rings and the planet itself. It's just not as concentrated.
Right, exactly. My gosh,
the maneuver.
The speed. I'm sorry, but just the speed. Whenever I read about things that happen,
space is crazy.
But it's not even just space. Like I can wrap my mind around the fact that like the Earth is going, a bajillion miles an hour. But when I hear about human-made objects that are going a bajillion miles an hour, like that blows my mind that humans have that ability to make things like that.
Here's the thing with space, especially as it relates to like speed in space. There's nothing to slow you down.
Right.
So it's not like, when you're driving in a car, you have to keep your foot on the gas a little to maintain whatever speed you're going. It's like if it has any bit of, its foot on the gas proverbially, it will accelerate because there's no air resistance. There is no friction of the tires against gravity, against the pavement. That works to slow your car down. There's none of that. So it's like it can. I mean, obviously there is a finite point to it. It's not going to reach the speed of light, but 77,000 miles per hour is very reasonable for space.
No, like I understand that it's like I understand it's not that fat. Like, you can explain the physics to me and everything, and like, and all of that makes perfect sense. But it's still just absolutely wild that you know that human beings can just send a bunch of like dirt that we found and have shaped into spacecrafts or whatever, bunch of like dirt and wood and whatever else, and it can go that fast and that far. The physics of it all makes sense and you explain it well, but it's still it is, I don't know if humbling is the right word, but awe-inspiring, I suppose, knowing that human beings can do something that incredible.
Well, what makes it even crazier is the next
Oh
line,
boy.
which says, the maneuver, which was accomplished using only predictions. So it's not like we had a camera on this thing and someone was driving it. No.
Good Lord.
Allowed Cassini to gather unprecedented data on the ringed planet and was the closest any spacecraft has gotten to Saturn at that point in time. NASA said that the precision of the craft's movement could help future spacecraft perform dazzling maneuvers of their own.
I so in addition to just like human beings in general, nerds specifically, which I assume is like 100% of our podcast demographic here.
Oh, yes.
Just like, I mean, wow. That's that is all done with years in advance, I assume. That's all being predicted and calculated, and just my props to anyone that works on anything like that, where you really do need to be razor sharp with every calculation and every decision that gets made.
Yeah, 100%. And like that's why I know I could never do space things, because I just don't want that pressure on me personally to be like, oh hey, you messed up some math and there goes $5 or so billion of federal money. I accidentally launched this robot into Saturn. Sorry.
So now this, I might be totally making this up, but I thought I remembered hearing something where different space crews were working together and like they didn't coordinate metric versus imperial units, and something got screwed up because of that. Am I totally making that up?
I vaguely remember hearing about that, but I have no idea.
I'm gonna look this up real quick.
Okay.
Well, you are going to introduce to us the actual topic of the show.
Yeah, so I did spoil for Mike a little bit what we're going to be talking about, just that it was about mass extinctions, which are something that we have talked about on the podcast before.
It's a fascination of ours.
Yeah, so we've talked about the end Cretaceous mass extinction in probably the most detail, the one that most people know. Big asteroid from space comes down and supposedly kills the dinosaurs.
Asterisks.
But as we talked about, it's never that simple.
Mm-hmm.
And we sort of brushed through some of the other mass extinctions in our 600 million years in 60/120 minutes. So, but here we're going to be talking about something that's a little buzzwordy lately, which is something known as the sixth extinction. Is that something that you might have heard about?
It has crossed my radar that I believe it's. Are we currently living through a mass extinction event?
That's what we're here to talk about.
All right. So yes or no?
We will get there. I'm not going to tell you the end before the story starts.
Well, it sounds like we're already at the end, but go ahead, continue.
So, the reason why it's referred to as the sixth mass extinction, referring to, the previous, quote unquote, big five, which we have talked about in geology and paleontology for quite a long time. Those would be the end Ordovician mass extinction, the late Devonian mass extinction, the end Permian mass extinction, the end Triassic mass extinction, and then the end Cretaceous mass extinction. And that goes from oldest to most recent.
Right.
So this entire semester, I've been taking a seminar style class about mass extinctions. Basically, we read 2 to 3 papers per week, and then we all sit down and talk about them, and we kind of have one person, 1 or 2 people that lead the discussion for that week. And so we've talked about, all of the previous mass extinctions, and as we've sort of alluded to, they're way more complicated than you think. We used to sort of think, in order for life to be changed so drastically, there must be some single really drastic change that brought that on, such as big asteroid hits Earth, everything dies.
Right.
But we now know that, with one exception, none of them are that simple. The only one that is that simple probably is the end Permian mass extinction, which, if you remember back to that, I think that was still in the first portion of the 600 million years in 60 minutes.
I'm going to trust you on that one.
Yeah, I believe it was in the first half. But the end Permian mass extinction is the worst of them, meaning that during that mass extinction, depending on what data you look at, somewhere between 90 and 98% of all species went extinct.
Man.
Yeah. And the cause of that was, obviously there were other global things happening, but the single cause of that was an area roughly the size of the continental United States under a kilometer of lava for a few 100,000 years.
That'll do it.
Yeah, that'll do it. So that's the only one that had like a single cause. Or even if you can say, like I said, there were other things going on at the time, and our data aren't perfect, So there definitely were things going on at the time other than that.
Right.
That probably played, a part, but that's the only one that you can even argue has like a single cause. Some of the other ones, you can argue, aren't even mass extinctions. Particularly the end or late Devonian mass extinction, just because like fundamentally nothing really changed. Typically with mass extinctions, you get a big turnover in what kinds of things you see. For example, at the end of the end Cretaceous, you no longer have dinosaurs or other large reptiles like that. At the end of the Permian, with the end Permian mass extinction, that's when you start to get archosaurs, which are the group that the large group that dinosaurs are in, starting to become much more common. Whereas before that, you had our ancestors, actually, synapsids, were sort of filling most of the major niches.
Right.
So that doesn't really happen with the late Devonian mass extinction. Is like, yes, a lot of species dies, but fundamentally, there aren't a ton of new large scale groups that fill in the spaces of the things that died. So all of that to say, mass extinctions are much more complicated than people think they are.
And I would think that they're pretty complicated. So
Right. However, in recent years, and I want to make this very clear before I even start talking about the sixth extinction, I'm not meaning this in any way to downplay all of the extreme climate and everything else that humans are doing to mess up the planet. I'm not downplaying that at all. That's obviously extremely serious, something that I care personally a lot about.
As do I.
However, that is sort of the basis that people use for saying that we are currently in the middle of mass extinction number 6.
Right.
And frankly, based on the evidence that I've seen, that is not true.
Okay. So I guess so we are leading with people are making a claim that Gavin does not agree with.
Yes. And again, I'm not saying that we're not killing lots of things very quickly. That is absolutely happening. But so I'm basing this off of a handful of papers that we read for that class. So for example, there was a paper that came out, what year was this? 2011. So in the grand scheme of things, relatively recently. Titled, "Has the Earth's 6th mass extinction already arrived?" That's the title of the paper.
I forget what the there's some internet rule that says whenever there is like a question in the title of a headline, the answer is always no.
They argue yes.
Right. Well, so you are arguing no. So go ahead. Let's lay out the best kind of devil's advocate. Let's steel man the other side.
So so you want me to make their case for them and
Yeah.
then
What's
explain
what
why?
case are they
Okay.
making in this paper here? That's in 2011, so a decade ago.
Hmm.
The sixth mass extinction has already begun.
Yeah. So essentially, they lay out, data about, each of the main groups that are very ecologically significant in in modern ecosystems. So the groups that they sort of look at are mammals, birds, reptiles, amphibians, ray finned fish, which is most of your fish besides sharks, uh, scleractinia, so that would be most of your corals, gastropods, so that would be snails and their closely related animals, bivalves, so clams and such, um, cycads and conifers, different kinds of plants, sharks, and decapods, which are most of your crustaceans, things like crabs, lobsters. Um, so they sort of look at some, you know, modern slash also a little bit of, human scale history records of those groups and compare how many have been extinct in the last handful of 100 years. And like it's a lot. I'm not gonna pretend it. I'm not gonna pretend it's not.
Hmm.
However, uh, that's sort of they also sort of predict. They look at the rating that what always forget the name of the organization that actually does this, but like that figures out what animals are endangered, what animals are critically endangered, when animals are threatened, vulnerable, that kind of thing. Um, so you take a look at because there's a complete open database that organization uses. I think it's like ICUN. I think I don't remember what that stands for, but I believe that's the
See
acronym.
here, it looks like there's a couple different ones, but I'll keep looking that up as you're
Yeah,
talking. So basically, before can I take a guess as to what your thesis is with all of
sure.
this? So it sounds like what you're trying to say is because of climate change and other human related activities and possibly other things, that you are like there is cause for concern for lots of species, but like there should be a different word, like like instead of mass extinction it should be like big extinction event, or like something something that's kind of lower on the scale that indicates that something is like there's a problem, but that we're not quite at the level of a mass extinction event. Is that sort of what you're getting at?
Yes and
Okay.
no. So the main problems that I have with this, especially this paper, was that they start their abstract with which for anybody who doesn't read scientific papers often is basically a summary of the entire paper in like a short paragraph at the beginning. You read that so you decide if you want to actually read the rest of the
Right.
paper. So they start the abstract with paleontologists characterize mass extinctions as times when the Earth loses more than three-quarters of its species in a geologically short interval, as has happened only 5 times in the past 540 million years or so.
Okay.
That is
Geologically short interval seems like a kind of weaselly phrase.
so. That's not even the part that I have a problem with.
Okay.
We don't have a definition for mass extinction.
So
We
where did they
don't.
pull this from then?
I don't know. I literally like that's what something we talk about. We're like, I don't know where they got this from
Interesting. Okay.
because, like I said, depending on what data you're looking at, some of the big five mass extinctions don't even fit that. Um, and then also geologically short interval. What exactly does that mean?
Right.
Because for that, I believe I kind of get the end Ordovician and the late Devonian confused sometimes because those are the two that didn't fundamentally change a ton about their like global ecosystems. They just a lot of stuff died.
Right.
But I believe it was the end Ordovician one, but like uh, how did we phrase it? It just happened in a really long amount of time relative to a lot of the other mass extinctions. So, like I said, with the end Permian, it was, a few 100,000 years to like tens of thousands of years scale. Geologically, that is very short. The end Cretaceous mass extinction was on the scale of probably decades to hundreds of years. Very, very quick.
Right.
However, the end Ordovician, depending on how you categorize it or how, because it occurred in several pulses, depending on if you consider those pulses the same event, which some people do, some people don't, then that could have lasted like 20 million years. I personally wouldn't call 20 million years geologically short. It's not long, but it's also not. I definitely would not categorize that 20 million years as short.
So it sounds like, in addition to, any number of problems, there needs to be sort of a well accepted definition of mass extinction event before we can actually start calling whatever is going on now a mass extinction event. And the one that they're using just isn't. It sounds like it just doesn't quite cut the mustard.
Yeah, that is mostly what the problem with at least that specific paper was. Although this was the first paper, to my knowledge, to really raise this question,
Mm-hmm.
which I think it was the actual purpose of having the title be an actual question.
Right.
But yeah, I just don't think it was written. The paper was very much written for biologists. Like, you can tell because like they include, and like the person, the lead author on the paper is a person named Anthony Barnosky.
Right.
He is a very, very well regarded paleontologist, mostly focusing on pretty recent stuff,
Mm-hmm.
but he has done a ton of really, really valuable work. So like, I'm not saying that I know more about this topic than he does,
Mm-hmm. Right.
but like, this paper specifically was written for biologists, and the reason that I know that is because they have a specific box laid out in here, so separate, taken out of the body of the reading. So it's like this: the author really wants you to, if you don't read the rest of the paper, read this. But they explicitly, the box is titled "Severe Data Comparison Problems," which, to anyone who works in paleontology, we're like, duh. That's like easily the biggest problem with paleontology, is that sometimes we just don't have enough data, because sometimes fossils don't like to cooperate and don't like to show up where we want them to. So sometimes we just don't have fossils that we would like to have, or that would be useful for our comparisons. But the fact that he has to spell that out means that this, to me, says that this was not written for paleontologists.
This was written to get like clicks.
Not necessarily. I wouldn't even say
Okay.
that. I would just say that he was writing this for so the opposite of paleontology is neontology.
I didn't know the opposite. What the?
So paleo meaning old,
Right.
Neo meaning new. So
Okay.
it's just the study of like modern ecosystems and such.
Okay.
Most, I mean, neontology, and I'm sure this isn't actually like 100% true. To me, neontology and like ecology
Mm-hmm.
are fairly similar, are pretty much synonyms. So,
It seems to make sense.
but this was written for people who study modern ecosystems. And so with that, like he does sort of go into defining mass extinctions, but I'm like, we've known about mass extinctions for hundreds of years now, long enough to define some of our largest chunks of time based on them.
Mm-hmm.
The two of the three eras of the Phanerozoic eon. So it would be your Paleozoic, which was from like 540-ish million years to 250-ish million years ago. That one ends in a mass extinction. The Mesozoic, which is when the dinosaurs were around, that ends in a mass extinction. That one starts and ends in a mass extinction. And then the one that we're currently in, It hasn't ended yet. So it might end in a mass extinction. But, two of the three have ended in mass extinction. So we've known about them for a very long time. And yet we still can't even nail down exactly what one is.
Right. So,
Um,
so is another way to put this that like we are way too early in whatever's going on to say we are in a mass extinction to say that so confidently.
Absolutely.
Okay.
That is like the biggest takeaway that we all had is we're like, well, we're still in it. And, we also got into a really interesting conversation about, uh, you know, as we've talked about before, I think also in the second part of 120, 600 million years and 120 minutes, but that we used to have a lot of real big mammals running around until very recently. We had things like mammoths and giant sloths, and though that's just the tip of the iceberg for like really really big mammoths
Right.
or really big mammals that were running around at the time. And it's like, do you consider all of them going extinct part of the same event, or because very few of them have concrete evidence that humans were directly involved in their extinction?
But we can
So
all like, couldn't we like, wouldn't the devil's advocate to be like, like it's difficult to tie any one extinction to humans, but like, boy, a lot of them are going extinct, right as humans are, taking over the globe.
right, and like, yes, obviously if you are a bird on an island, yeah, you're probably going extinct. But again, it's very hard to directly tie, like you said, directly tie human interference to any individual extinction.
Right. Okay.
So I don't know. I just kind of wanted to have a conversation about this thought of a sixth extinction, because this is something that I've thought a lot about and something I actually used to like be a much bigger believer in before I got more into the data and learned more about mass extinctions, because it really does highlight like regular people know what a mass extinction is and that it's pretty bad.
Yes.
And to say, hey, we're causing this, in my opinion, like if you're going to try and scare the bejesus out of people, at least be factual while you do it. And it does not seem that's actually the case.
So if we're talking about kind of having a more of a conversation tone to this, a lot of, the sixth mass extinction event, it's sort of based around the idea of climate change, like you said. And
Not
oh, okay,
necessarily.
go on.
So I don't mean to
No,
interrupt
go
you.
ahead.
But so they break it down into a different paper. This one from just last year, from 2020,
Okay.
breaks it down into 5 categories. So they break it into habitat alteration, which is things like deforestation, biological resource use, such as hunting, climate change, pollution, and invasive species. So those are sort of the 5 categories that they look at. And they
Mm-hmm.
sort of further subdivide that into mammals, birds, and reptiles. And then they also look at to see if there were different effects between herbivores, omnivores, and predators. And like their findings were actually kind of interesting in that the biggest effect seemed to me to be pollution, invasive species, and habitat alteration.
And have okay.
So, and the main reason for that is because if you think about, I think the biggest part of habitat alteration is habitat fragmentation.
And what habitat
Because,
fragmentation, is that what you're saying?
go ahead.
So
Yes.
what is habitat fragmentation?
Essentially, if you have a great big forest and you put a road right in the middle of it,
I can see why that would be a problem.
and if you go from having a great big forest to two smaller forests, and it makes it much less likely for animals from one of the now two small forests to make it into the other one. And then, as you further subdivide that, there's just much less available area and much less directly connected area for them to use. A really great example of this is with orangutans.
Okay.
So orangutans, they're not really hunted. They're not directly affected by pollution, really, but they're heavily impacted by deforestation because it's typically not like humans just start at one side of the forest and just work their way in. They sort of start like an optimal point and sort of just kind of meander. It's very suboptimal if you look at it from like an engineering point, like standpoint, but
Not too well thought out at the beginning.
right. So they kind of just break up forests into little patches.
Mm-hmm.
And what that does is it means like, yeah, so if you have like 1,000 orangutans or so, and you take up or you split that forest that they're in, if they're all in one big continuous forest, and you split it up, even if you maintain like the total amount of forest, so it's like you don't take away any forest, you just split it up, those orangutans can now no longer get from one patch to the next. Then so that basically just causes a lot of like inbreeding in each of the populations and really decreases like gene flow and can really become a big detriment to each of those populations because they can no longer be as genetically diverse, which opens them up to things like disease or like a new parasite or something that like maybe one population can fight off, but the other ones just for whatever reason their genetics don't allow them to. They're not naturally immune to it or more resistant to it. And then one population goes completely extinct, becomes locally extinct.
I never would have
And
considered the gene, like the genetic diversity part of it. It would
mhm,
like that's and that makes total sense. But whenever always thought about like human impacts on on habitats, it's always been like way more of a brute force. Like um uh we are you build a road through a forest and then like there winds up being a bunch of roadkill. I never even thought about the just you are making much more insular habitats that for obvious reasons are going to lead to a lot of problems.
exactly. And like one of the biggest factors that like I say we, but the ICUN or whatever that
I
organization
actually looked
is.
that up. The International Union for Conservation of Nature, IUCN.
Okay, so thank you. But yeah, one of the biggest factors that the IUCN looks at is how endemic is that species. How locally constrained is it? If it's only found like on one island or in one small corner of an area, that population has a huge potential to go extinct just because you know if you look at say white-tailed deer, if you screw up part of white-tailed deer's habitat, okay, they have a bunch more habitat, they can live basically wherever.
Not a good thing, but like not the end of the world for that species.
Right, but if you screw up the habitat for a species like orangutans that only live on a small handful of islands, um, if you screw up their habitat, they don't really have anywhere else to go. So that's why orangutans, at least I don't know if they still currently are. I would assume that they are, um, but really, really highly threatened to go extinct. And yeah, it's there are so many factors that go into extinction, and that's another thing is that we don't really understand extinction all that well in modern systems because a big part of it is that like that assumes that we know everything that's going on in our modern world, and we absolutely do not. So that assumes that we are aware of every species, which we're definitely not. It is assumed that we only know about a quarter, if that, of like the total uh, number of species of beetles, and there's like almost a million species of beetles.
That's another thing that I always just like. I love finding is like how little we know about like the planet we're on. We know more about other planets than the depths of the ocean or species of beetles.
Mm-hmm. Well, and it's like that's another thing is that all of the stuff, and granted, this might just be because we are Our program in general, not everyone in my program is vertebrate focused, but in general, the program at my school is pretty vertebrate focused. However, vertebrates make up a very small amount of the total amount of animal life out there. Like I said, beetles are a quarter of all animals. Why are we not looking more at beetles? You know?
I'm assuming this kind of goes back to our funding episode. Like, is anyone going to fund that research?
So like I'm sure that there are people that are doing that. And we actually had a conversation today because we this was a once a week class and we had our last class today.
Mm-hmm.
Um and so we were talking about plants actually as well. And like, do we really understand plants? Because I mean, I know myself, I personally don't understand plants much at all. But like, so plants are so weird relative to animals in that like they can hybridize with plants not even that closely related to them. Like the equivalent of like, I'd say like more distantly related than like a cat and a dog.
And they're able to like form these, bastardized, hybrids with each other.
Completely naturally.
Huh.
And the babies can have babies, unlike, like a horse and a donkey, which makes a mule, which is infertile, you know? So plants are totally weird in that sense. And a lot that factors into like, okay, how do we even measure extinction in plants if like, so okay, this species of plants goes extinct, but like there's this other species that's like a hybrid between where it's like 25% of that extinct plant and 75% of some other thing. How does that even work? I don't have an answer to that question. And then we also talked about things like fungi, you know,
Mm-hmm.
like, and we actually did look that up. Like we are having a pretty sizable effect on at least terrestrial fungi. I don't think we talked about like marine fungi because those do exist.
Oh, wow.
Um,
Okay.
well, I mean, the land based ones had to come from somewhere.
Yeah, fair enough.
Um, but yeah, so it's like there are so many things that we don't understand about our current ecosystem that it's like, okay, to say that enough things are going extinct to warrant a mass extinction, I just don't think you can ever confidently make that argument with how much missing data we have. And immediately, I kind of regretted those words as I said that because, as I mentioned earlier, paleontologists very frequently have less data than we would like.
Right. But doesn't that mean you
However,
like, you have to kind of hedge on your opinions a little bit? You're not going to say this is that, or, this isn't that, but like the data doesn't support that, or, we need more research, but it's trending in this direction. Doesn't, don't you kind of hedge more than you might otherwise like to because of that, lack of data?
yeah, I would. Well, I'm going to exclude the dinosaur people from this one, but in general, paleontologists tend to be generally pretty conservative in our data
Right.
interpretation because we recognize that we generally don't have the amount of data that is generally considered that modern ecologists do. We can't we can't set up like a trail camera somewhere and monitor whatever ecosystem we're studying.
Mm-hmm.
We just can't do that. And so generally, yeah, as I sort of alluded to, sometimes, and I'm not saying it's only the dinosaur people that do this, because I've definitely read, mammalian paleontology papers that also do this kind of thing, but I've noticed it a little more with the dinosaur people. Um, but yeah, and I think that that's something that plays a little bit into this, people claiming that we are currently in a mass extinction. I think it comes down to a large factor of a handful of things. A, them not understanding that we don't fully understand what makes a mass extinction.
Okay.
B, people wanting to be like, hey, what's going on right now is real bad and we should stop it, which is coming from a good place, and undoubtedly there is data to back that up. that we are causing things to go extinct at a higher rate than normal. 100%. I will
Hmm.
not argue that. But, uh, so between them not understanding, how mass extinctions work, them wanting to raise a red flag, and then, a little bit of, hyperbole, as much as I hate that this is true, you can't kind of rule that out as like, oh, sixth mass extinction, that'll get published, you
Right.
know? As sad as that is, and I wish that wasn't the case, it kind of you can't ever immediately rule that out when looking at a paper.
Can't you also like? Isn't it a part of this? I think I mentioned this before. Just like the fuzziness of the you mentioned it. I should say the fuzziness of the term mass extinction. Like because that doesn't have precisely defined boundaries, people can sort of take that term and sort of make data to fit the conclusion.
A little bit. And again, I don't want to suggest that, these authors are doing that because obviously that is bad.
Right. Right. And there's they're not. This isn't based on nothing here. Clearly, it sounds as though they're doing some reasonable science, but some of the conclusions that they're drawing could be based on the data that we currently have, could be reaching somewhat.
Yes, absolutely. And it's like, um, for example, I also think just some of the choices that they used for their data wasn't great because in the second paper, the one from last year that I'm sort of looking at here, they break up a lot of their things into, so like I said, they use mammals, birds, and reptiles, and they broke those down into predators, omnivores, and herbivores.
Hmm.
And then they further broke that down by environment. And one of the environments that they used was marine oceanic, so like deep water, offshore stuff.
Right.
Um, and it said, let's see, 100% of marine oceanic mammalian herbivores
Marine,
are
oceanic, mammalian, herbivores. So what?
exactly. Can you even think of what that animal
So
is?
water animals that are in the ocean, not just like a
Mm-hmm.
river, I assume, but like the ocean.
Right.
Mammalian, so they're mammals. Herbivores that
Yep.
eat only plants.
Yep.
God, I mean, I don't. A seal? Like, no, seals eat. No, I don't. I have no idea. I don't have a clue.
Um, so
A whale?
that's also what we thought because they didn't include like a table of what exactly fits in what category.
That
From what I can tell, they're talking just about manatees and dugongs.
dugongs?
Yes, I know that's the name of a Pokemon.
I, I
It's also so it's basically a manatee but less chunky.
I don't know. I pulled up some pictures of this guy, and he looks adorable.
They're very cute, but they're seafaring. They tend like depending on like the population, they tend to stick more toward the shore, but it's I like I said, like I can't even think of what that animal would be other than I think there's like two species of dugongs and one species of manatee with some subspecies, but like other than those, I can't even think of what that animal would be. So it's like anytime that I saw like something that was like 100%, I'm like immediately suspicious of that.
Somebody, so this was said to me in a sports context, but I think it applies here. Whenever you have something that seems like, either a fun fact or like something that blows your mind, but the more qualifiers it has, the less interesting it becomes. So if it
Hmm.
was, 100% of something is happening, that might be a big deal. But if it's 100% of this subset of this subset of this like the
Right.
more the more you add it, like the less impressive and the more somebody might be kind of, again, we don't certainly want to, put malintent on the people who
Hmm.
are doing this, but the more people might be kind of playing with some numbers.
And like I definitely agree. Like I agreed with the base assumption that like you should split up these data because like a let's see, a reptilian predator that lives in the savannah is very different than and is under completely different pressures than one that lives in like a swamp or a wetland.
Hmm.
So they're being impacted by climate change in very different ways. So like breaking them up by sort of habitat, I agree with, but they didn't really go a ton into how they, uh, you know, how they went about splitting them up, and like didn't even have like a table of like, and like maybe it was in some like supplementary data that we didn't have access to or didn't get, you know. Um, but like yeah, that was just another, that was one big problem that several of us had just as we were discussing the paper amongst ourselves. Like, okay, but I don't know what species they're talking about for which thing.
Right.
And it's like, how do you truly, define an omnivore? Are dogs omnivores? They actually eat surprisingly more plant material than you would think in the wild. But most people would consider dogs, like wolves, a carnivore.
Yeah, and that's one of those terms that seems easier in fourth grade to figure out than in the real
Yeah.
world. Like when you're actually writing in scientific papers, you should be defining your terms probably better.
Hmm. So, in closing, this was a little bit of a rambly episode, but it was an episode that was kind of timely because of Earth Day. Because I honestly, for Earth Day, I had wanted to do like an actual episode about climate change and stuff like that, but I just didn't have the time to prepare that as much as I wanted
Right.
to. Um, and so this just kind of fit because we were talking about it in one of our classes. Like I
Yeah, and
said,
so what's the if you want to, like you said, this was a bit of a rambly episode, but to just kind of put a nice button on it, when it comes to the state of are we living in a sixth mass extinction event, what is the official verdict of this podcast?
based on that phrasing, no, we are not. However, they sort of ignore the fact that, so the big five, in quotes, mass extinctions are what is considered first order mass extinctions.
Hmm.
There are lots and lots of like second and third order mass extinctions.
Okay.
So, for example, there was an event in the Carboniferous period. So, uh, let's see, 300-ish million years ago. I don't remember exactly when it happened, other than it was in that period.
Hmm.
But it's an event called the Carboniferous rainforest collapse. The Carboniferous is called the Carboniferous because almost all of the coal, at least in like Europe, which is where it was named from, is from the Carboniferous period. And because there was a ton of trees, basically the entire planet was like rainforest essentially. And within the span of a very short amount of time, the rainforest ecosystems just completely collapsed. Then you get sort of like the deserty conditions that you see throughout most of the Permian period, which is mostly what the Permian's known for, is for being pretty dry. That is a very notable event in Earth history. It didn't affect animal life all that much, but it had a huge impact on plants. And that's not considered a first order mass extinction. I think that might even be considered like a third order mass extinction. However,
I assume just for
every
clarification, I assume this as you go down from 1 to 2 and 2 to 3, that is a less significant mass extinction event.
yes,
Okay.
yeah, but every paper that I've seen that talks about this current biodiversity crisis, which I feel like is a more accurate term to use than mass extinction, every paper I've seen talking about it compares it to the big five, you know,
Hmm.
and I don't think that that's the right way to frame it. Like, if you're gonna compare it to mass extinctions, and granted, that might just be because we have the best data for those five relative to any of the, third or second order ones, but we are not even close to being on the scale of, like, I would say almost any of them. Like, we could potentially be, and I think it's worth looking into.
Hmm.
But to make that claim right now, I just don't see that being accurate.
Is there a period of time? Let me rephrase this. During our lifetime, so you and I are both in our mid 20s.
Right.
If we lived, a normal amount of time, would we be able to look back with enough data you think we'll have at that point to could like definitively say yes or no? Like we have the data, we can say that it did or did not reach this first order mass extinction event. Or is that something that's going to take much longer than the lifespan of a typical human being?
Well, I mean, like I said, the end Cretaceous mass extinction happened on the order of decades to 100 years ish.
Okay, so it's possible.
Granted, the recovery period was a lot longer,
Right.
but yeah, so it is possible. And to be honest, the way things are currently going, that would not surprise me if we had enough data to say that by then. By the time 2070 or so rolls around, that wouldn't surprise me. But I don't know. I like to have a little faith in humanity.
I'm glad you like to. I'll be the pessimist on the show in that case.
I said I like to. That doesn't mean I do.
All right. Well, this has been a kind of a fun, more conversational episode than we normally do, and I definitely enjoyed that. And with that, we are 20 episodes deep, and
Happy Earth Day, everyone.
happy Earth Day, and here's to the next 20. So this has been our next episode. Our podcast will be Old Enough to Drink.
Yeah, does that mean that we get to have a beer with it?
You haven't been this whole time?
You have.
I've actually been.
We need to have a conversation after we get done here.
I've actually been dry for every episode that that we have recorded, and for next episode, nothing is going to stand in my way. And with that,
we do not condone underage drinking on this podcast.
Not underage drinking.
So we had to wait until it was 21.
But of age drinking and podcasting, absolutely.
Absolutely.
With that, this has been episode 20 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. That is Gavin. Gavin, cheers till next week.
Absolutely, buddy.